Parameters of quadratics. So, a parameter is a variable that we pretend that we know the value of, such as a, b, c, r1, r2, h, or k. And usually we'll be given those values, but we're going to look at how those change the graphs of various quadratics. So, a I usually refer to as the tightness, b as the starting slope, and c as the y-intercept. This one is not an official name, but the rest are. So let's first look at what stays the same. Well, they all have the same y-intercept of 3. There's another thing that's the same between all of these. And here what I've done is I've fixed 2 as b, 3 as c. What I'm changing is these are different a values. So you see positives in the top, negatives at the bottom, and we're going from fractions to 1 to 3. So 1/3, negative 1/3, 1, negative 1, 3, and negative 3. I'm going to continue this pattern throughout the video. So they also all have the same slope at that point. What changes here, there's a lot of things that change, but one of the things that is going to be the most obvious is the width and direction of this parabola. So the width is changing and the direction, now this is going down. These were all opening up, but these are getting wider and opening down. So the width is changing as it gets to be further away from 1. The width further away from 0, the width becomes smaller. Closer to 0, the width is wider. And if they're positive, they're facing up. If they're negative, they're facing down. Now I've fixed A to be 1, C to be 3, and now B is what's changing. So let's look at what's the same. What's the same is they all have the same y-intercept. They all have the same width. They all have the same width. If you go about 1 unit up, you'll see that they're all about the same width at 1 unit up. Now, what's different is their slopes. So you see the slope is getting bigger among the positives and more negative among the negatives. So that's what's changing. The vertex definitely moves, but it's not quite as obvious how that moves. The slope is what's changing there. Now here I've fixed A and B, and C is what's changing. So what's the same here? Well, the width is the same, the width is the same, width is the same, width is the same throughout. Can't see that there because it's further down. Another thing that's the same is the slope is going to be that same slope at 2 throughout. You can't see that down there because I'm trying to keep the graphing window the same. But what's different is the y-intercept. So 1/3, 1, 3. Negative 1/3, negative 1, and then down to negative 3 is going to be where the y-intercept is there. So this literally shifts it up and down. So that's why I call this the y-intercept. So this is the most interesting part of standard form, that C is our y-intercept. Now we're going to look at vertex form. A has not changed, but now we're going to look at H comma K, the vertex. So here, A is what's changing, and I fixed K, AH and K to be negative 1 and positive 2. So you're seeing that the vertex has stayed the same for all of these, and what's changing is just the width and direction. So that is way clearer than in the standard form one, but it still is A. It's still the same value. It's just that it's easier to see the difference when what's staying the same is the vertex. So larger numbers are tighter and smaller numbers are wider. If it's negative, it's going down. So that's how A affects the graph. H, now I've fixed A, so they all have the same tightness, the same width. But what's different is the location of the vertex. And now the location of the vertex is moving left and right. As I make h positive, it moves to the right. As I make h negative, it moves to the left. Notice there's a negative sign in here. So this one would look like, x plus 3 squared plus 2, because plus 3 is minus negative 3. So that moved 3 to the left based off of h being negative 3. And then here, the widths have stayed the same because a is fixed. Another thing that stayed the same here is the x-coordinate is negative 1 throughout. What's changing here is the position of the vertex up and down. So you see it moving up and down. K represents the vertex's y-coordinate. So now you see h comma k is truly the vertex. As you change h and change k, you change left and right, up and down. Root form. You still see tightness again, the first root and the second root. So here, what you're seeing is I've fixed the roots in all of them to be negative 1 and negative 3, negative 1, negative 3, negative 1, negative 3. You'll see that they all have those same roots. What's changing is that tightness. So the way that looks is the width of this changes throughout. So that's how the tightness looks when the roots are what's staying the same. Now, if the tightness stays the same, but you change the roots, well, what I've done is I've left them all with the same root of negative 3. So they all have one root as negative 3. But then I've changed what the other root is. So here, one of the roots is 1/3, one of the roots is 1, one of the roots is 3. Now the other root is also negative 3, negative 1, and negative 1/3. So now you see how the formula affects the roots. So putting it all together, A is the tightness, B is the starting slope, C is the y-intercept, h comma k is the vertex, r1 and r2 are roots. So how do we use that? If this is the graph of ax squared plus bx plus c, what's the graph of ax squared plus bx minus c? What changed? Positive c changed to negative c. So here, this is our c. This is our y-intercept of 0, c. So that changing it to negative c would move it down to 0, negative c. And everything else would stay the same. So I would take that same curve and I'd write it like that. If this is the graph of ax minus h squared plus k, ax minus 2h squared plus k. So what changed is h turned into 2h. So I increased h by h. I took h and then I added h to it to get 2h. So here is h comma k. So we need to move that over to 2h comma k. So this will be the new graph, shifting it to the right. Here, a times x minus r1 times x minus r2. So the roots are staying the same. What's changing is we now have a negative a value, so it'll look reflected over the axis. Thank you.